By late 2022, training a modern artificial intelligence required running billions of calculations inside massive specialized data centers, and the entire global supply chain required to build those centers was effectively controlled by the United States. Three companies held a near monopoly on this process, and they required to physically print those chips. Even though TSMC and ASML are not American, they rely heavily on U.S. software and patents. This triggers the Foreign Direct Product Rule, giving the U.S. government legal leverage to halt trade by any company that uses their intellectual property. The U.S. government used that exact rule to cut China off from the world's most advanced AI chips, aiming to prevent them from securing a structural advantage in global scientific and military research. Without access to the raw processing power required to train modern AI models, the domestic Chinese technology sector was cut off from the physical hardware necessary to compete. Yet today, Chinese foundation models like Qwen and DeepSeek are consistently outperforming top-tier Western models on major industry benchmarks. These models have already penetrated deep into American digital infrastructure. Major U.S. tech companies like Pinterest, Airbnb, and the rapid growth coding assistant Cursor are actively customizing and running their systems on top of Chinese artificial intelligence. And despite the fact that it costs millions of dollars to train these massive datasets, Chinese companies are making these highly capable models available to developers around the world completely free of charge. How did a severe hardware embargo result in a more efficient, resilient, and globally dominant Chinese AI industry? First came the hardware bypass. Cut off from TSMC, China leaned entirely on its largest domestic semiconductor manufacturer, SMIC. Using older manufacturing equipment pushed to extreme physical limits, SMIC managed to produce advanced chips capable of connecting smartphones to 5G networks. But those domestic chips were still significantly slower than NVIDIA's state-of-the-art hardware. To survive, Chinese engineers had to write radically smarter code to compensate for the lack of processing muscle. With a mixture of experts, the AI divides workloads into specialized clusters. DeepSeek pushed this further, slicing its model into 256 micro-experts. When solving a problem, it activates just 8, keeping the rest asleep to slash computing costs. They paired this with a method called multi-head latent attention, a technique that compresses the AI's short-term memory by over 90%. This allows the model to analyze massive documents and hold long conversations without overwhelming the hardware. This chart compares the estimated financial resources required to build these models. By utilizing brilliant software to compensate for weak hardware, DeepSeek produced a world-class AI for roughly $6 million in training costs, exposing the billions currently being spent by Western labs. China also scaled this efficiency into physical infrastructure. The government issued a mandate to stop treating computing power as a private product and start treating it as a public utility, much like electricity or highways. They established the National Integrated Computing Power Network. This allows a small tech startup in Shanghai to rent cheap, centralized computing power online from massive state-backed data centers, eliminating the need to buy their own expensive hardware. To train models on this centralized grid, Chinese companies tap into vast domestic data pools. Platforms like WeChat and ByteDance provide billions of text, audio, and video interactions every day, creating massive reserves of training fuel. With these highly efficient models fully trained, Chinese companies introduce their market bypass. They release the open weights, the core files required to run the AI, giving them to global developers entirely for free. But the free model is simply a loss leader. When a developer builds an application on Alibaba's Qwen model, they eventually need massive storage, security protocols, and enterprise software to keep that app running reliably. That is where Alibaba's paid cloud services step in. The model itself is a customer acquisition strategy. By offering world-class AI for free, these companies draw global businesses directly into the broader Chinese digital ecosystem. Pointing to smuggled chips or isolated cases of copied data to explain China's rapid AI progress ignores the physical reality of what they have constructed. They engineered a highly capable parallel ecosystem out of strict resource constraints. This introduces a critical requirement for the modern state: sovereign AI. Artificial intelligence now functions as the foundational infrastructure for global supply chains, scientific research, and defense systems. If a developing nation relies exclusively on foreign AI models, a single geopolitical dispute could immediately cut off their access to the intelligence required to run their economy. True sovereign independence requires a country to construct its own integrated ecosystem. That means securing domestic computing power, training local engineering talent, and owning localized data pools. The US hardware blockade restricted physical chips, but its lasting legacy was forcing China to develop the software efficiency and independent infrastructure necessary to thrive in the intelligence era.